So that's the status until, well, now I think, but there's now WebSockets, which is quite new in HTML5. So it's something that looks like that. It's a WS:// protocol, but it's actually still HTTP, but it's just been a little bit here, not there, modified. So this is just like a normal HTTP request, but in the header you put an upgrade header here, along with the origin header to say where the connection is from. And you get a response saying, okay, the server actually supports WebSocket protocol, and doing all the handshake of some weird text here. So this establishes a WebSocket connection after that. And then you can start doing bidirectional messaging between the server and the client. But right now, messages must be in UTF-8, I think. So, and all this handshake is quite new in draft 76. I don't know why, but here's the code that supports the handshaking. If you can read it, it's kind of crazy. It's like the number of space in this thing to be divided by all the numbers concatenated as a decimal number. What? I don't know who invented it, but it's crazy. But it's only 5 lines in Perl. Right. So after the handshake, all the messages are surrounded by 00 and FF bytes, and then you can have UTF-8 in it, and then from the server and the client. So you can have pieces of messages, and the API here will allow you to send and get the messages. So in JavaScript or in the client, you have the unopened message and close and arrow callbacks. And on message, you just get an event, and then you can get the data of it, which is the chunk being sent by the server. Right. And so you notice here we can create a WebSocket to a random web address, right? Not just the local host. But the server must accept your origin header to say, right, I accept the connection here. So this is a mechanism allowing a cross-site connection for WebSockets. So, like I just said here, on connection, the client sends like where this connection is originated from, and if the server accepts that, then it responded with the send origin header and say, okay, I actually accept that. So, if you're a website that provides services like Ajax service endpoint for other vendors or stuff, you can check the origin header to see if the connection is actually from a trusted site or something like that. Okay. So it's a lot of different topics. Now we're putting it all together. So that brings us to Hippie. So like we mentioned earlier about comment being like a long hair star, right? So what happens to a long hair web? It's Hippie, right? So what Hippie actually does is it abstracts the common layer for persistent connection between web server and the client. So it's either over WebSocket or multiply HTTP request. So if you use it, it looks like that. It's a normal PSGI app that you enable the middleware web Hippie there. And here in the normal PSGI app, you get an environment as well, and a little bit additional things in the environment, such as the arcs and handle. And then you can check the path info to see which path is dispatched to, and which correspond to the connection initialization and arrow and client-side messages. So it's kind of like a little bit weird abstraction, but it's just making use of existing PSGI semantics. And of course, here in the past, you can also enable other middleware to handle stuff, which I haven't done, but it's possible. So after you build this app, you just mount it to /Hippie, /_Hippie. And it's the default endpoint for the client-side library to connect to that. that you should be doing. So another restriction for that is that you must use a PSGI server that supports the PSGI non-blocking interface, which is the streaming interface and also the non-blocking interface that the sub can return another sub to be called later. So currently, which means that you have to use Twiggy or Fearsome as their choices. Okay, so but not everyone is already on a browser that supports WebSockets, and MSHI is kind of I don't think it works in IE. So it's kind of a very restricted environment if you choose to use the solution to provide bidirectional communication between server and client. So we must relax the Hippie a little bit, right? So Hippie must be relaxed. So what do we use to relax the Hippie? Yeah, I think something like that. So there's another module called Hippie Pipe, which, well, actually it's not called that pipe. It's about more, provided more instantiated connection instance that you can use overly. And so apart from WebSocket and Multiply SHR, it supports normal time pooling from the client. So you imagine that there will be a token saying this is the client, and then every time, if the client is using some old browser or things, that you can just call this URL with this token to get new messages for this client. And to do that, we also need to support to pull in the message queue support, because you have to know this is the client that is going to receive these messages. So the queue has to be persistent. So here's how you use it. After enabling Web Hippie, you also enable Hippie Pipe to make it relaxed. And you give it a bus. So here is an example. I'm just using AnyMQ new. So this is in process bus. So like in earlier examples, you can also use the AnyMQ instantiate with the MQP trait. So that will be shared across the servers. So here, it's becoming a little bit different from the callback that we see from just raw Web Hippie. You get another argument such as listener bus, and then you dispatch to handle new listener error messages. So new listener is like when there's a new connection coming in, you can use a callback to see if you want to subscribe to a particular topic by default or something. You can see an example here. So if we create a topic called news, and in the new listener callback, which means when we match the pass info to new listener, you can subscribe the current subscriber to it. So everyone who's newly connected to your Hippie will be subscribing to the news, the topic. So later, somewhere else in the code, or even if you're using MQP, then some other server, when you publish the topic to the topic with something like JSON, like type news YAPC message something, that this will be available to the subscriber. Okay, but what does this do in the client side? And because this is on server side, that the publish goes into the subscriber. So here it goes to somewhere else. Ooh, where is it? Ah, here. So in the client side, you instantiate Hippie pipe and stuff, and you bind the events here. So the events are mapped as the message.yapc, news.yapc, which is the type just here, as you can see the type. So this connects to the client and server without you actually doing too much heavy lifting. So it's kind of nice. And here, you can see you can use HPipe, Hippie pipe send some other messages like that, and this will get to sorry, it's a bit long to the message handler in the PSGI server that you can say you want to match the pass info to messages, and you can then check the message here. Okay, and again, you can choose to republish the message like that. And in the client side, again, you bind into some other message matching the type. Does this sound clear? Yeah, well, it's actually quite easy, and it's just like just a little bit of Perl and a little bit of JavaScript, and you have some fully connected and talking client servers. So, Justice gave me a talk 12 o'clock today, and he's just re-implemented a new slide software that makes use of Hippie. So I invite you to join the talk. Actually, there's the only talk at that time, right? So everyone should be there and then see Hippie in action. But if you must go to lunch or something, I have something to show you right now. Oh, not that. Right. Smaller. So this is a simulated real-time market from yesterday. As you can see, this is moving, and there's a chat room next to it that people can talk. And you can place simulated orders by keystrokes. So when I press Control down, it means selling. And that's a sound effect for selling. And if you do Control up, of course it's buying. That means you lose money and things like that. And you can place limit order here. So it's like a simulation environment, and because these two are the same users, so you can see the order is actually synchronized. If I do that, here is the same. It's the same. So it's just some bits of messages from the server and the client, and everything integrated. So if you have a large application, you can divide it by messagings, and then it becomes very easy with HTML5 WebSockets and this kind of toolkit in like Hippie. So yeah, let's try it. Make some money. That means you made money. Okay, so what else? Well, I guess that's the demo. So I guess that's pretty much it. We're running early, but we were running late. So so any questions? Questions.
Some more questions.
Yes.
Does AnyMQ support 0? Is AnyMQ? Does AnyMQ support 0MQ?
The question is, does AnyMQ support 0MQ? Well, the answer is no. And if you're listening, I would say I would love to see that being implemented by someone.
All right, then I guess I have to do it.
Yes. Right, so I hope you get to play with Hippie and all the exciting new technologies. And I think after Jesse's talk, he will put the slide software somewhere that you can hack on and add more cool feature to it. And so if there's any question, thank you. And then you can catch me somewhere for conversation. Yeah, thank you.